Hello, friends. Good morning. This is Ajay Kumar Jaina. Uh, we'll be starting with design of IC engine parts, which is the last unit of your syllabus. Today, we'll talk about IC engine definition, classification, terminology. IC. These are the points to be discussed today. So first of all, we'll talk about the definition of internal combustion engine. What is an internal combustion engine is? The engine in which the thermal and chemical energies by the combustion of fuel gases are released inside the cylinder is called an IC engine. There are engines where combustion takes place outside the engine also. These are called external combustion engine, like your thermal power plant, your steam power plant, and nuclear power plants. Their heat generated is outside the cylinder. Then these are called external combustion engine. Whereas your bike engines, car engines, and gas turbine engines are internally combustible engines, because combustion is done inside the cylinder. That's why these are called internal combustion engine. The efficiency, if we'll talk about the efficiency of engines, both the engines, thermal efficiency of ICE engine is greater than the thermal efficiency of uh, external combustion engine, because your combustion is done inside the cylinder. So whatever the combustion effect, that will be utilized very effectively. That's why the efficiency of ICE engine is greater than the efficiency of your thermal efficiency of your external combustion engine. So next we'll talk about the classification. There are various ways to classify ICE engine, various ways. And first of all, we'll talk about on the basis of fuel used, what types of fuel we are using. That depends upon the classification. So if you are using a petrol engine, petrol fuel, or gasoline, petrol is also called gasoline, then it is called a petrol engine. If you are using a diesel, then a diesel oil or diesel fuel, then it is called a diesel engine. And also if it is if you are using a gas, that is gas, and you are igniting it, it is also called a gas engine. Now, unlike in gas turbines, which are used for peak load applications in industries or in area where there is peak load requirement, we are using gas engines or gas turbines. Secondly, on the basis of method of ignition, how we are igniting the fuel, or igniting the fuel inside the cylinder, how we are igniting, and on that basis we are classifying spark ignition, and because there is a spark plug, and petrol engines are generally spark ignition, because we are giving a spark in spark plug, and combustion occurs in the combustion chamber. Similarly, compression ignition, what happens in compression ignition? We are compressing, we are first of all we are suction, we are taking a charge to the cylinder, then we are compressing. Charge means here only your air, here charge is only air, we are compressing it, and and we are injecting fuel inside the cylinder, and fuels, the air, compressed air's temperature is so high that it will auto ignite the fuel. As a result of oil, the charge, both the mixture, fuel and the air will burn. So this is in compression ignition engine, generally suited for diesel engines. Now, on the basis of method of on the basis of thermodynamic cycle. What are the cycles used on the basis of thermodynamic cycle? We are Otto cycle and diesel cycle and dual cycle. Generally dual cycle we are not preferring. Generally Otto cycle and diesel cycles are used for your engines. Otto cycle, which is that is a constant volume cycle, that two constant volume process and two isentropic process are there in Otto cycle. So we are using that thermodynamic cycle to for the operation. Similarly in diesel cycle we are using your constant volume and constant pressure, and we are getting and two isentropic process. This is here on the basis of thermodynamic cycle. There are various other cycles also, but generally we are using diesel cycle and Otto cycle. Now on the basis of strokes of the piston, there are 4-stroke and 2-stroke. When one revolution takes place in 4-stroke of the piston, then it is called a 4-stroke, and when one revolution takes place in 2-stroke of the piston, then it is called here 2-stroke. On the basis of cylinder arrangement, if cylinders are placed horizontally, then it is called horizontal cylinder. If cylinders are placed vertically, then it is called vertical cylinder. If cylinders are placed inline, that means one cylinder after another, then in order to get more torque or more power, so we are adding more cylinders, and then it is called inside cylinder. Similarly, V cylinder engines are there. If one cylinder is placed here and another placed here, then such a engine is called V engine. And also there is radial engines. Here cylinders are placed radially, then it is called radial engines. On the basis of application, we will talk about on the basis of application, where automobiles, motorcycles, and aero engines, locomotives, and stationary engines. Stationary engines, all of you know that what is automobile and motorcycle and aero engines and locomotive. A stationary engine is that is your you can say generator, electrical generator you are using. You are taking diesel fuel and you are producing electricity in that. That is a stationary engine. So on the basis of mode of ignition also, on the basis of mode of ignition, we are categorizing battery ignition and magneto ignition also. These are the classification. Now talk about the terminology. If we'll talk about the terminology, we'll see that there are terms which is inlet manifold, that is outlet manifold. This is clearance volume, that is top dead center, or the what is in between that top dead center to the extreme of the cylinder, extreme position of the cylinder, it is called top dead center. Similarly, here from top dead center to the bottom dead center, it is called the swept volume. That is also called stroke volume, swept volume, elapsed volume. These are called. Now comes to bore. What is the bore? This is the inside diameter of the cylinder, that is called the bore. Generally, bore diameter we are using in design, that is called bore diameter. And now comes to your top dead center. In top dead center, the extreme position of the piston on the top of the cylinder is called the top dead center. It is also called inner dead center in horizontal engines. That means this is the stay. This is there is a stay, so the piston will not move further. Then this position is called top dead center. Similarly, the piston will not go beyond this position in the bottomward direction, so it is called bottom dead center. this it is in vertical engines. If cylinders are placed vertically, then it is called top dead center and bottom dead center. If cylinder is placed in yeah, horizontal, then it is called inner dead center and it is called outer dead center. Now stroke, stroke, the distance traveled by the piston from TDC to BDC, or the maximum distance traveled by the piston in the cylinder in one direction. That means in one direction, what is the piston travel? It is it is called stroke. It is also in terms of twice the radius of the crank. Generally in ICE engines, that stroke is measured in terms of the radius of the crank. So here 2R, twice of the radius of the crank is called the stroke. Now called clearance volume. We know that this is a clearance volume because efficiency also depends upon this clearance. That is also expressed in some bikes, that is also called cc. Total volume also in terms of cc. So clearance volume is the volume of contained in the cylinder above the TDC is called the clearance volume. So it also helps, this clearance volume is given in order to the fresh charge inside the cylinder, so that the next stroke can be achieved. That's why we are taking a clearance volume. It is expressed in cc and cubic centimeter or cubic meter. Swept volume swept by the piston in one stroke is called the swept volume. It is expressed as total volume minus clearance volume. Yes, this is if you'll see that this is your stroke volume. So what will be the stroke volume? This is your total volume of the piston, total volume of the cylinder minus the clearance volume will be the stroke volume or swept volume. So now comes to swept volume. It is very important point in compression ratio, because compression ratio is very important for designing a ICE engine. So compression ratio, what is the compression ratio? The total volume by clearance volume. So its value, total volume, its values varies from 5 to 10 for petrol engine. 5:1 instead of compression ratio, 5:1 you can say, or 10:1 for petrol engines, and for diesel engines 12:1 to 22:1 diesel engine for diesel engine. This is very important. These are the very important terms used in a ICE engine. Also there are other terms like your compression rings and oil rings. There are cylinder liners, there are cylinder heads, there are various piston rodders, Gudgeon pin. There are various terms that will be discussed in the next class. Thank you.